Hello, Hera.
Hi, Hans. How are you doing today?
Oh, I'm doing great. Tomorrow, I'm attending my little brother Pons's birthday party, and today I'm getting all of the ingredients I need to get together to bake a cake. Since everyone knows how much I like treats, I was charged with this very important task.
That is so exciting, Hans. What kind of cake are you going to make?
Well, Hera Pons really likes catnip, so I'm gonna make the catnip cake.
That's a great idea, Hans. But have you ever made a catnip cake before?
Well, no, but I was just gonna use my favorite cake recipe and dump a bag of the catnip I usually buy at the store into the cake batter. Oh, it'll be great.
I'm not so sure about that, Hans. When cats eat too much catnip, they can get an upset stomach. If the bag you buy is too large, the amount of catnip per slice of cake may be too large, and all of the cats at the party will get sick.
Oh no, I didn't consider that. Pons will have a fishbone to pick with me if I make everyone at the party sick.
Don't worry, Hans. We can figure out just the right amount of catnip that you should add to your cake mix. Catnip cake is a standard menu item in the bakeries around here. We will call all of the nearby bakeries and ask them how many paw grabs of catnip they add to their cake and the size of their cake. They will be happy to help a fellow feline friend in need. Let's split up the calls and reconvene tomorrow. Okay, Hans, so let's put our list together and take a look at the data. Here are the names of the bakeries that kindly shared their recipe with us, the size of their 1-inch tall cakes in square inches, and the amount of catnip in paw grab units. We can plot the data from the bakeries on a graph called a scatter plot. The x-axis of the graph is the size of the cake, and it is what we refer to as the independent variable. The y-axis is the number of paw grabs of catnip, the dependent variable. What this means is that if we know the value of the independent variable, the size of our cake in our case, we may be able to predict the value of the dependent variable, in our case, the amount of catnip to add to the cake. We can see in the graph that all of the data points seem to congregate in a line, spanning from the bottom left of the graph to the top right of the graph. The correlation coefficient R is 0.90, which indicates a direct correlation between paw grabs of catnip and cake size.
That's good, Hera. That means the amount of catnip to add to a cake is dependent on the size of the cake. But none of the bakeries make my size cake, which is 64 square inches. I won't know how many paw grabs of catnip to add to my specific cake with this list from the bakeries.
Actually, Hans, yes you can. Since we can tell from our scatter plot that paw grabs of catnip and the cake size are correlated linearly, meaning the data points resemble a line, we can then use something called simple linear regression to draw a line that will closely resemble the pattern of the data points on the graph, also known as the line of best fit. If you remember from kiddie school, the equation for a straight line has two components, a y-intercept and a slope. The line of best fit will also have these two components. The y-intercept from our line of best fit is negative 0.0476, and the slope is 0.0368. These are called regression coefficients. The meaning of the y-intercept is the value of y. In our case, the number of paw grabs of catnip, when x, the size of the cake, is 0 square inches. The slope is the amount that y, the number of paw grabs of catnip, changes for every 1 unit change in x. In our case, for every square inch increase in cake size. The really neat part about this regression equation is that we can figure out how much catnip will be needed for any size of cake you will ever make.
Wow, Hera, this is really convenient.
Yes, it is, Hans. Let's take the regression equation and plug in the size of your cake to see how much catnip you need to add. If we plug in 64 square inches into the equation, y equals 0.0369 x minus 0.0601, y will equal 2.30 paw grabs. This means that you will need 2.30 paw grabs of catnip for your 64 square inch cake.
Good thing we used regression. The bag I was going to use had 6 paw grabs of catnip, which would have been way too much for a 64 square inch cake. I'd have had to make a 164 square inch cake with that much catnip. That'd be so much leftover cake. Thank you, Hera.
You're welcome, Hans. I don't want to complicate your life even further, but I want you to know that there may be other things besides the cake size that could impact the amount of catnip you should add to the cake mix. For example, the temperature you cook the cake at could deactivate some of the beneficial properties of catnip, like the calming effects. This could mean that both the size of the cake and the temperature of the cake could impact the amount of catnip you should add. We'll talk about this later, but I'm thinking that to be on the safe side, you should just go to the bakery and buy a cake for Pon's birthday party this year.